Tokyo's final refuse disposal site. A huge area, but it is filling up rapidly, and the city faces a major problem finding a replacement. Tokyo's 23 wards are making great efforts to encourage recycling and to reduce the amount of waste created, but there will always be a need for disposal. Combustible residential waste can be burned as fuel to generate heat and power, which also reduces its volume. An efficient waste treatment cycle can play an important role in saving energy resources and helping the move toward a society that places less burden on the environment. Much of our waste can be recycled or reused. By learning to treat waste as a reusable resource, we can greatly reduce the amount requiring disposal. However, there will always be a large amount of waste requiring treatment and disposal, and this is a fundamental problem every society must face. Combustible waste is incinerated. This reduces its volume by 20 times, thus helping to extend the life of the landfill disposal site. Incineration is also a very hygienic method since it destroys harmful bacteria and insects. The Chuo Incineration plant began operation from August 2001. This plant has three notable features. Firstly, it employs the latest technologies to prevent pollution, including the release of dioxins. Secondly, the plant has been carefully designed to blend in with the surrounding area, forming part of the local urban development plan. And thirdly, the incineration process is also utilized to generate usable heat and electricity, contributing to the creation of a more sustainable society. A waste collection truck arrives at the plant. The refuse weighbridge records the amount of waste as well as details of each truck for use in collection system management. From this point on, the truck drives through enclosed roadways inside the plant. Odors are prevented from reaching the outside by automatic doors, which open only to allow trucks access to the platform, and by a curtain of blown air. This is the platform. From here, the trucks tip their loads into the refuse bunker. Bunker gates are opened automatically when sensors detect an approaching truck. The refuse bunker provides temporary storage for the waste. About 10,000 cubic meters in size, it can store a 4-day supply of refuse for the incinerators. Two refuse cranes are used to spread the refuse in the bunker to prevent it piling up unevenly and to mix the contents uniformly. The cranes also transfer the refuse to the refuse hopper, which is the entrance to the incinerator furnace. From here, the refuse is fed in a continuous stream through the furnace. This plant has 2 furnaces, each capable of treating 300 tons of refuse per day, so the plant can incinerate a total of 600 tons of refuse every 24 hours. The latest automatic combustion control equipment is used to ensure that refuse is burned under highly stable conditions. Incineration for 2 seconds or more using combustion gas at 850 degrees Celsius prevents the generation of dioxins. This is what a furnace looks like before use. The fire grates are arranged in a stepped configuration. As the grates move forward and back, they convey the burning refuse in a steady stream toward the bottom of the furnace. Let's see how the incineration process works. From the hopper, the feeder gradually pushes the refuse into the furnace. Inside the furnace, different sections of the array of stepped fire grates perform different functions. The top section dries the refuse and provides preliminary incineration. The middle section applies fierce heat for main combustion, and final combustion in the lower section ensures that any remaining refuse is fully incinerated. Refuse is conveyed steadily from top to bottom to be completely incinerated and output as ash. The air for incinerating the refuse is force-fed into the furnace from below the fire grates. The air is blown through narrow gaps between the fire grates. Different kinds of refuse burn at different rates, and the amount of air can be finely adjusted to ensure optimum combustion conditions. Air for the incinerator is taken from the top of the refuse bunker. This maintains a constant negative air pressure in the bunker, which prevents odors from escaping. All odors are completely destroyed during high-temperature combustion in the furnace. The ash which is left after incineration is removed from the furnace by the ash extractor. Water is added to damp down and cool the ash, which is then taken by conveyor to the ash bunker. The ash bunker provides temporary storage for the ash. From the ash loading hopper, ash is loaded onto trucks for transportation to the final disposal site. Scheduled for completion in 2005, the ash melting facility at the Central Breakwater Inner Landfill site will treat the ash from the Chuo Incineration plant. Melting the ash reduces its volume by half, thus helping to further extend the life of the disposal site. Any potentially harmful residues in the ash are safely trapped inside the resulting slag, which can be used as paving and construction materials. The plant operates continuously 24 hours a day, centrally controlled by a computer system. All operation and monitoring is managed from the central control room. Let's look at the pollution control system. Exhaust gas produced by incineration passes through 4 main treatment processes before being emitted from the stack. These are the gas cooler, the bag filter, the gas scrubber, and the NOx reactor. This is the gas cooler. Here, the gas is rapidly cooled to about 150 degrees Celsius in order to prevent the dioxins from recombining. Slaked lime and a chemical agent containing activated carbon are blown into the gas, which is then passed into the bag filter. The bag filter equipment is located next to the gas cooler. It contains a large number of fabric filters, which remove particulates and dust from the gas. Each cylindrical filter is 16 centimeters in diameter and 6 meters long. Made from special glass fabric, they filter out various harmful substances as well as removing dust. Hydrogen chloride and sulfur oxides in the exhaust gas react with the slaked lime and stick to the filters for removal. During incineration, combustion is controlled so as to destroy most dioxins. The small amount that is emitted is absorbed by the activated carbon, allowing it to be trapped by the filters. The gas then passes to the gas scrubber. Here, a solution of caustic soda absorbs and removes hydrogen chloride, sulfur oxide, and mercury compounds. This is the NOx reactor. Ammonia gas is blown in to break down nitrogen oxides into harmless nitrogen and water. And any dioxins remaining from the bag filter process are broken down by the action of a catalyst. Harmful substances having been eliminated, the flue gas is finally released into the atmosphere from the plant's 180-meter-high stack. The Chuo Incineration plant was designed to harmonize with the surrounding community of Harumi, forming part of the urban development strategy of Chuo Ward. The exterior of the plant was carefully designed to present a pleasing and varied appearance. The enclosed roadways inside the plant's grounds are covered with public spaces and gardens. This provides another pleasant leisure space for visitors to Harumi.